Here are two more questions on kinetic theory of gases. Let's begin with the first one. From certain apparatus, the diffusion rate of hydrogen has an average value of this, while that of another gas is this. Identify the gas. So we've been given the diffusion rate. Now when we discussed kinetic theory of gas, we found out that the diffusion rate of a gas is proportional to VRMS, and that in turn is proportional to 1 upon square root of molecular weight. So this was the equation that we discussed when we were discussing kinetic theory, kinetic energy of gas. Now in this case we have no idea about VRMS, that's not given. We have some idea about diffusion rate, and since we know one of the gas, hydrogen, whose molecular weight is 2, so I know diffusion rate and molecular weight. So I'll use this equation. Let us say diffusion rate is denoted by the symbol R. Therefore I'll get this equation R is proportional to 1 upon square root of M. R is proportional to square root of 1. Therefore R1 upon R2 is equal to square root of M2 upon M1, and therefore I'll get M2 upon M1 is equal to R1 square upon R2. And our object is to find out and get an idea about M2, and from the molecular weight of the second gas we'll be able to get an idea about which gas it is. So M2 upon M1, M1 is 2 because we have got hydrogen gas, molecular weight is 2. R1 by R2 whole square, so I can write this as R1 is 28.7, whereas this is 7.2 whole square. Let us do this calculation. What do we get? 28.7 divided by 7.2, 3.98. So approximately this will be equal to 4 square, and that will give me 16, and therefore I get M2 as 32, and the gas which has a molecular weight of 32 is oxygen. Therefore the other gas is oxygen. This is how we get an idea about the molecular weight, and from that we are able to guess which gas is it. Let's move to the second question. An ideal gas is expanding such that Pt square is constant. Find the coefficient of volume expansion of the gas in terms of temperature T. Now coefficient of volume expansion is dV by V into T. It's the change in volume per unit rise in temperature. Right? This is the definition of coefficient of volume expansion. Just to revise this, what is coefficient of volume expansion? It is change in volume per unit original volume per unit rise in temperature. As the temperature increases, the volume of the gas increases, and that volume per unit original volume. This is known as the coefficient of volume expansion. So basically we want to find out this in terms of temperature T. Okay. Now we have been given Pt square is equal to some constant, let us say some constant K. So we have Pt square is equal to K. Also we know that Pv is equal to mu RT, and therefore P is equal to mu RT by V. If I can put this value over here, this value of P is put over here, so I'll get mu RT upon V into T square is equal to some constant K. Therefore T cube, T into T square will be T cube, is equal to K, V comes over here, and we have mu R over here. So we have T, relationship between V and T. We wanted to find out dV by V in terms of T. So we have a relationship between T and V, and the other terms are constant. K is constant, mu is constant, R is constant. So I can differentiate this with reference to T and this reference to V. So I'll get 3T square dt is equal to K mu R dV. So this is the equation I have got. Therefore now I can write down dV by dt. dV by dt is equal to 3 mu R T into T. There T square, so I am putting it separately as T into T, T multiplied by T, right, upon K. Now is equal to, now pay attention to this part. What is mu RT? Mu RT is PV, right? So for mu RT I can write down PV. I will keep this T. That is why I separated these two T. So mu RT is PV. And what is K? K is PT square. So I put those values over here. So 3 PV into T upon K is PT square is equal to PP will get cancelled, TT will get cancelled. So 3V upon T. Therefore, dV by dt is equal to 3V upon T. And therefore, dV by V into dt. I bring this V over here, so I got V over here. This will give me 3 by T. And therefore, I can say that the coefficient of volume expansion for this gas, which is following the equation Pt square is equal to constant, is 3 by T. Thank you.